Okay guys, so I'm going to go over section 2.7 per a couple of requests, and I'm just going to do 1 through 19 odd, all of them. All right, so section 2.7 was the limit of a function, and I just want to remind you real quick that, you know, we have our derivative definition. Where a is the point at which we want to find the slope of the tangent line or the derivative of the function. Okay. Now, when we have something like the limit as x approaches a number, could be 0, could be any number. Okay, that's a little bit different. We're looking at what is the height of the function when x is approaching that number from the left and the right. Okay, so completely different things. So let me go over there. I've got the problems up here on my iPad, and I'll probably use my iPad a little bit, because in the first part, questions 1 through 9, it's all calculator. You're just going to investigate what's happening on the calculator. And I will tell you that when you use the calculator to investigate a limit, you need to look at your window or your table, rather. All right, and so to do that, you're going to press a second window for the table set. Now mine's set on something weird here, but I'm just going to change it, start it from 0, and I'm going to use a change in step, or a step change at 0.001, so I can get really, really close to the number in question, and I'll show you why in a minute. All right, so in problem number 1, they want us to find the limit as x approaches 0. So you see these are not h's here, they're x's. Okay, so as x approaches 0 in each case here. And you should know by now that there's going to be a problem, because we've got division by 0 if I were to plug that 0 in for x. And so that in itself is going to be an issue. So this is not what is the derivative of the function at the point where x is equal to something. It's what's the limit of the function when x is approaching 0. Okay, this is not the derivative. So in the first one, and you can do this from your home screen or you can do it from the graph screen. I'm going to do it from both. If I do it from the home screen, what I'm going to have here is, let's see, parentheses are, yeah, no, let me do it from, not the home screen, I'm sorry, the table screen is what I'm thinking of. All right, so let me use parentheses. So we've got root x plus 1, okay, under the square root, minus 1, close the parentheses, divided by x. Okay, so it's really important if you have more than one term in the numerator or denominator to put them in parentheses so your calculator can do PEMDAS correctly, and hit the graph key, right? And so we're going to investigate this thing. Now I can see if I come in from the left of 0, it's a number, and I come in from the right, it's the same number, it's the same height. But I don't know what that height is, and I can't find it using second calc 1. That will give you a y-intercept, because if I press 0, you're going to notice here at the bottom it says y equals. It can't give me a number, and the reason is if you shut off your, if you do second format and shut off your axes and hit the graph key again, you'll clearly see there's a hole in the graph at x is equal to 0. All right, so I need to find that height, and the way you're going to do it is through a table. So you're going to use second graph key, and that'll bring up your table, and here's 0, and you see there's an error there because there's a hole in the graph. And what you're going to do is you're going to investigate 0 from the left. Okay, so you know, it's 0.5008, 5006, 54321. So this is getting closer and closer to 0.5 as we move closer and closer to 0 from the left. And let me just scroll down a little bit more. If we come in from the right hand side, you know, so at 0.993, 94, 95, this is moving closer and closer and closer to 0.5 as well. So the limit from the left and the limit from the right are both 0.5. And so therefore we would say that the limit is 0.5. The height of the function at x is equal to 0. Let me put my axes back on. Okay? So now I can find that point exactly. In the second case, we've got the function e to the 1 plus x minus e to the 1. Well, e to the 1 is e, so you can just use your e key. You know, it's just, oops, I forgot my minus. So you can just use e, because e to the 1 is e, and I forgot parentheses. So let me throw one in there. And then we're going to divide that whole thing by x. Hit the graph key. And again, we know we're going to have an issue at x is equal to 0. And in fact, I can't see that good in this window, and I need to see what's going on. So I'm going to change my window. I'm going to go up to a y max of 5. Hit graph again. You need to be able to see the point in question. And again, if I come in from the left and the right, I know the height is some y value, but I just don't know what it is because I can't use second calc value. So again, I'm going to go to my table, and here's my problem right here at x is equal to 0. So if I come in from the left, it looks like this thing is getting closer and closer to 2.72, I'll say. And if I come in from the right, it's getting closer and closer to 2.72. So I would say the limit as x approaches 0 for that particular problem is 2.72. In number 5, we've got the cosine of x minus 1. Forgot my parentheses again, divided by x. Let me throw the other one in there. Hit graph. And in this one, it's pretty clear. From the left and the right, so I come in, what's the height? It's 0, okay? If I look at my table to verify, you notice just to the left of 0, I've got 5 times 10 to the negative 4. And coming in from the right, it gets closer and closer to negative 5 times 10 to the 4. Well, 5 times 10 to the 4, or negative 5 times 10 to the 4 is 0. So the limit there would be 0. All right, so I'm going to do the next one. The next one is x sine 1 divided by x. Again, these are all as x is approaching 0 in this particular problem set, so I'm looking at the point where x is equal to 0, and it's really a little bit crazy there at 0. And if I trace 0, enter, and then zoom in to investigate that region, oops, now my window's out of whack here, so give it a second to finish spinning here, and then I'll adjust the window. I'm going to adjust my y-axis. Let's see, my y-min, I'll put to negative 3. Oops, I meant negative 3. Hey. Y-axis. Negative 3. There we go. Okay, I want to see what's going on here because, you know, it could be a sharp corner, but this thing's just oscillating back and forth. But regardless, as I come in from the left and the right, it looks for sure that the limit of this thing is 0. And if I double check with my table, here we go. Here's my problem, right? I come in from the left, 8.3 times 10 to the negative 4, that's 0. 8.3 times 10 to the negative 4 is also 0, so the limit is definitely 0. And then finally, we had 1 plus x. Real nice functions here, all to the 1 divided by x. And I'll graph this. I'm going to do a zoom 6, which is a standard window so we can see it a little bit better. Again, as we approach 0 from the left and the right, it is approaching the same number. I just don't know what it is. So I'm going to go to my table. And here's 0. As I come in from the left, it looks like 2.71 2.720. As I come in from the right, it looks like 2.720 if I round. So I would say that's what the limit is. Now, in 11, there's a bunch, and I don't remember if I gave you all the subparts to number 11 or not. Let me just move my camera up a little bit. But this is super important because in this section here, they want you, it says each of the following limits is the derivative. They're reminding you that, this is h going to 0 now. It's not x is approaching 0. So this is the derivative definition, all right, or the limit definition of the derivative. So what we want to know is, it says identify the function n a and use your calculator to estimate the value of the limit. Well, here's what you do. Whenever you see some number plus h anywhere, change it to an x. So you see this one, this whole thing's an x. This one is an x. Why? Because it tells you what your function f of x is 2 to the x. What's your a in this case? Well, your a is whatever number was added to h. Well, a is 3, so my a is 3. So what I need to do is I need to find the limit on that thing. Now you can do it from the graph screen, so I'm just going to remind you that you can put 2 to the x into your calculator, hit the graph key. Focus that a little bit. Focus. Oh, that graininess in the screen is a killer. And then you could do second, draw 5 at x equals to 3, and your tangent line will be drawn and it will give you the equation. So it looks like, and I know that that's really hard to see, but it looks like the slope of the tangent line there is 5.545, right? I'm going to do it from the home screen, right? So we're going to do math 8 with respect to x, and our function was 2 to the x. Let me just check my editing software here because it made a funny noise and that concerns me. Seems to still be going. Okay, and we want the derivative at x equals to 3, and there it is, 5.545. So that's my derivative at x is equal to 3. In this one here, my function is 2 sine of x, and x is equal to 3 again, right? So from my home screen, so if you don't know how to copy and paste, you should learn. It's real easy. What it does is it's just going to copy and paste the last thing you typed in. It will not copy and paste the answer. So if you press second enter, you see it just copied and pasted. I'm still doing it x equals to 3, so I'm going to leave that alone, but I'm just going to change my function. So I just pressed the delete key, and that one was 2 sine x. Right? And I'm going to hit enter, and my limit is negative 1.980. Or not my limit, my derivative, I'm sorry. My derivative is negative 1.980. Again, if I were to graph that function, 2 sine of x, hit the graph key, here it comes. And if I do second, draw 5 at x is equal to, what was that again? 3. So at x is equal to 3, hit enter, it'll draw the tangent line. It's definitely negatively valued, and it's negative 1.980. Alright, so same as you got here. So what I'm going to let you do is the rest of these, you shouldn't have any problem now. I'll just help you identify the functions. So for this one here, my function is root x. And the point at which I want the derivative at is when x is equal to 1, right? And this one here, my function is tangent x. Oops, that's an equal sign, equals tangent x. And the point that I want to evaluate it is pi over 4, and so forth for those. Okay, if you have any more questions on that, just shoot me an email. Let's see, number 13. Yeah, I'll just use the iPad. Number 13, we're looking for the limits at various points here. Okay, this is the function g, calling it the function g, and we want to use the graph to evaluate each quantity. So in the first one here, it says the limit as x approaches -2. Well, remember, the limit only exists if and only if the limit from the left equals the limit on the right. So taking a couple of pens here, x equals -2 is right here. So if I come in from the left, my height is -1. If I come in from the right, my height is -1, and so therefore I'd say the limit is -1. In part B, when x is equal to 1, well, here's 1. If I come in from the left, the height is 1. When I come in from the right, the height is 1. So I would say the limit as x approaches 1 is 1. In the next question, they're asking, what is g of 1? Well, g of 1 just means what's the function output value when x is equal to 1? Well, it's right here. It's -1. Okay, if I could pick this little point up with my hand and put it right there, then I could redefine that function and make it continuous at that point, but I can't because that's not how it's defined. It's defined as it is, and g of 1 is -1. This one here, part D, the limit as x approaches 3 from the left. So it doesn't want it from the right. It just wants to know what is it when we come in from the left. Well, if I approach 3 from the left, it's -1. If I approach 3 from the right, it's +1. Now the limit from the left does not equal the limit on the right, therefore the limit as x approaches 3 does not exist, and that's what you can write there. Capiche? And for 15, 17, and 19, I'm just going to do them on the paper. So, number 15, we have the limit as x approaches 0 of x over x squared plus x plus 1. And what I always tell students to do is plug in the number. If I plug in a 0, am I going to have an issue? No, I'm going to have 0 over 1. 0 over 1 is 0, so therefore I would just say that it's 0, the limit's 0. In number 17, we've got the limit as x approaches 0 of x cubed plus x over x. And if I plug my 0 in now, I'm going to have this indeterminate form, and that's the Calc BC part that you'll learn toward the end of this semester. It's your introduction to BC, so we cannot have this, all right? So what we need to do, since it's a rational function, is we need to factor and see if we can clean this up. And lo and behold, those are going to cancel. So what we're left is the limit as x approaches 0 of x squared plus 1. I can't clean it up anymore, and if I plug a 0 in, it's no big deal. My limit is 1. And in number 19, they're trying to trick you because it's a little different now. Now they want the derivative at x is equal to 3, right? You notice that these were h approaching something. This is these were x approaching something. This one is h approaching something. So this means, what is f prime of 3? Well, what's the function? The function is x squared, and our a is 3, right? So all we need to do in this case is use the limit definition, right? So anyway, we can just use this right here. So we'd say the limit as h approaches 0 of 3 plus h squared minus 3 squared, which is 9, over h, is equal to the limit as h approaches 0 of 9 plus 6h plus h squared minus 9 over h. And those 9s are going to cancel. So that's the limit as h approaches 0. I'm going to factor an h out at the top because we know we've got to get rid of that h on the bottom. And so now I can't simplify this anymore. So I'm showing the grader. What is the limit of this function? Well, now if I plug the 0 in for h, I get a 6. So the limit is 6. Now, since I know what the function is, where did I write it? Here. Again, you could easily do this in your calculator. We want to know when x was equal to 3, and our function was x squared. Okay, so we can verify it, and we get, we get 6. Okay, so there you have it. all the way to 19, 1 through 19. Okay, if you still have questions or you still need to understand something that you don't, send me an email and I'll be more than happy to help you. You will have a lesson up for tomorrow. It'll be section, I think I did 2.8, so maybe, I don't know, maybe I'll just give you the rest of the review. We'll see, but there'll be something up for you guys tomorrow to work on with the substitute, and I'll see you hopefully all on Tuesday. Have a good rest of your weekend.